Hey everyone, today we're going to explore how you can reduce the cost of incidents by empowering first responders with a type of automation called Automated Diagnostics. My name is Jake Cohen, and I'm a senior product manager on the process automation team here at PagerDuty. After today's session, you'll have a good understanding of the idea of automated diagnostics and a few strategic ways to get started. So let's set the stage here. Your team has someone on call. This person might be fairly technical, or they might be fairly junior or new to your team. Regardless of who they are, though, statistically and realistically speaking, they are not super well-versed in your entire technology stack. This might be you or someone on your team or someone on a more centralized response team. At the end of the day, they receive an incident. And it's their job to do one of two things: either identify and fix the issue, or triage or pull in other people based off of who is most likely to be able to resolve that issue. So either way, this person begins what they can to investigate, diagnose, and troubleshoot the incident. They're going to look at monitoring tools such as Datadog and CloudWatch. They'll execute some commands at the command line. They'll look in Confluence to see if there's runbooks for how to handle certain types of incidents. If they're really ambitious, they'll search Stack Overflow for how others have tackled similar incidents. But here's the thing. Many times, this first responder can't determine what the root cause is. And that may be because the incident is fairly generic, like this ELB alert. Or it's because, as mentioned earlier, they are a less tenured individual or less experienced in your particular environment. Or it may be that because this person is on a centralized team, they don't have access to all systems and therefore can't perform deep diagnostics on their own. So what ends up happening? Well, what ends up happening is of no surprise to those of you who have been in the industry for a while. The responder calls in the cavalry. Now, I want to pause here and mention that in a lot of these talks and discussions, we're typically using P1 and severity 1 incidents as our examples. But in this case, I want you to think about P2s and P3s. Let's call them medium severity incidents. They certainly require attention, but they're not an immediate all hands on deck scenario. Granted, many of the same principles discussed here do apply to P1s, but just keep the medium severity incidents front of mind. What this means is that the first responder pulls in a person or two to help investigate the issue. This could be through a formal escalation through PagerDuty, but it could also be that the first responder slacks these additional people to assist. But there's a chance that these people are unable to identify or resolve the root cause, so they ping someone else here, perhaps a developer. Now, that person might be more concerned with absolving themselves of responsibility, so they prove this issue is not due to their service. And this goes on and on until someone with the right level of skills and tribal knowledge and or access is pulled in to assist with the incident. This process might take place over the course of a number of minutes or the course of the whole day. It's obviously going to depend on the severity of the incident and whether or not other symptoms come about. But this raises the crucial question: what is the best measure for the cost of an incident? Now, if an incident is impacting external customers and their user experience, then it's easy to say that the most important metric is the number of customers impacted and the duration of that impact. But what about when the impact to the customer is minor? Perhaps we're having trouble with a backend service in a particular region, and so customers are being rerouted to the next closest region that can provide that same service. They may not experience a major difference in quality of experience, but it's still a priority to figure out why that backend service went offline. From these types of incidents, and maybe even some of your higher priority incidents, the total cost of an incident, summarized here as TCI, is directly correlated to the number of people involved. Now, this likely isn't news to this audience, given that PagerDuty is purpose-built to route incidents and notifications to as few people as possible. But even with using PagerDuty to reduce alert noise and routing to the right team, it only goes so far in reducing the total number of people involved in entirety. So what are we getting at here? Well, what we're getting at is there has to be a better way. So let's first look at what happens when a first responder pulls in additional people with particular domain expertise. Typically, operators tend to perform the same steps when they are paged for incidents of a given type, and the steps they perform will usually be aligned with their specific domain expertise or prior experience in this environment, or based off of the specific access they have to certain systems and resources. For example, someone familiar with Kubernetes is going to look at Kubernetes events and pod logs. Someone familiar with databases will look at locks on the database, and a third person might check for memory leaks on their service. So the question is, how can we replicate this for your first responders? How can we make it so that when a first responder receives a notification in PagerDuty, these questions that the domain experts tend to ask are already present? Better yet, rather than just posting these questions and these recommended instructions by the domain experts to the first responder, can we automate these instructions so the first responder is provided with what we would consider diagnostic data? When the first responder sees the incident, they see information that was automatically and dynamically retrieved via queries to the underlying services and infrastructure. With this type of automation, when the first responder receives the incident, they are able to read through the diagnostic data and discern where to start investigating or who the best person is to pull in for help or who to escalate to. Now, it's worth noting here the difference between diagnostic data and monitoring data. Whereas with monitoring data, it's used for alert thresholds and anomaly detection, diagnostic data is used as the first steps of troubleshooting once an issue has already been identified. So as a basic example, monitoring tools will raise an alert based off of high or anomalous CPU usage. The automation here will pull for the top CPU consuming processes, as well as perhaps other information such as locks on the database that the container or VM is connected to. So let's look at this from a workflow perspective. The first responder looks at the PagerDuty incident, and either through event-driven automation or by the click of a button, PagerDuty's runbook automation product performs queries against the infrastructure and services like Kubernetes, MySQL, and AWS's services. Once that information has been retrieved and analyzed by the first responder, they can then pull in the correct person from the outset. Or if they have the right level of access and permissions and technical skills, they can begin troubleshooting on their own much faster. So let's see what this looks like in practice with a demo. In this demo, we will show how you can use automated diagnostics to improve incident operations and reduce the number of individuals involved in incidents. Imagine that someone on your team is on call and they've just received the following PagerDuty incident. This is saying that a synthetic check has failed, and this synthetic check pertains to the checkout service that is part of your overall e-commerce platform. Although there's some chance that a first responder knows how to deal with this type of incident, there's a likelihood that they do not know how to thoroughly investigate. This is where PagerDuty automation really comes in handy. As a team, you're able to provide responders with the ability to pull in diagnostic data from all critical components of a given service. So in this case, on the incident, I can see that I have the option to invoke this automation action called Retrieve Diagnostics. Before moving forward, I do want to show what this functionality looks like here in the PagerDuty mobile app. So I can click on our incident, on automation actions, and Retrieve Diagnostics. Back in the PagerDuty UI, when I click on this automation action, I can see a brief description of what this automation will do. For the demonstration purposes, I'm showing that I can invoke this automation by the click of a button, but this can be event-driven by integrating automation actions with event orchestration. So let's go ahead and click Run Job. What this does is invoke a job in our Runbook automation portal. What this is doing is running through a series of steps to pull that diagnostic data from the various components that pertain to this service. It's looking at the current pods in the relevant namespace. It's pulling recent Kubernetes events and logs from the pods within this service. It's also testing to make sure that Redis and Postgres are reachable and behaving normally. The authoring of this job was a collaborative effort by multiple people across perhaps multiple teams. And This automation is effectively replicating what the domain experts first do when they are pulled in to assist with an incident. So we can see the various commands that are executed against Kubernetes and the jobs that are used for Postgres and Redis, and the step to post all of that data back to PagerDuty. We can also see here that the automation is a place for us to document our procedures, include things such as the architecture diagrams in the portal, thereby further assisting end users. We can also see here that we can invoke this automation on an ad hoc basis as well. So let's go back into PagerDuty and see what the automation has provided for the first responder. Here we can see on the incident timeline that all of that diagnostic data has been provided. We can also see that one of these pods, the payment service pod, is showing that it is unhealthy. What this does is it points the first responder in the right direction of where to begin troubleshooting, or perhaps more importantly, it points them in the right direction of who the best person is to assist with this incident. Without this level of diagnostic data, the first responder may have looked at the details from the monitoring tool and figured that it was either an issue with the checkout service, since that's where this incident was generated, or with the CDN, for example, since it was a synthetic check that failed. Pulling in this diagnostic data means that if the first responder needs to triage or pull in more people to assist, then there's an improved likelihood that responders will pull in the right people and reduce the overall number of people involved, thereby shorting incident duration and reducing incident costs. Thank you. So in this demo, we saw that the first responder was able to invoke automation through the PagerDuty incident, and this called on runbook automation to execute a series of steps, such as pulling information from Kubernetes, Postgres, and Redis. This meant that the first responder didn't have to leave the PD incident interface to be provided with information that would help them identify the ideal person to pull in for assistance or whom to escalate to. This ultimately not only shortens the average incident duration, but it can significantly drive down the cost of incidents by reducing the number of people involved. With that, here's a few key takeaways from this presentation. Try to implement a strategy that empowers first responders, whomever that might be, to do more on their own. As part of this, one of the best ways to drive down the cost of incidents, both critical as well as medium severity incidents, is by reducing the number of individuals pulled in to assist with them. This can be accomplished by automating the steps that various individuals take when they begin investigating and troubleshooting those incidents. This ultimately leads to a culture of knowledge sharing through both automation and improved operations. And here's a couple of resources that highlight PagerDuty solutions for automated diagnostics. Finally, if you want to learn more about PagerDuty's process automation, I encourage you to check out these other talks that are happening here at Summit. Thanks so much and have a great day.